what you can do with this. It's going to be pretty much the same deal. Work on it a minute and then we'll put it up on the board.
And you don't have to always grab this, right? Would you just use the formulas?
You're probably going to want to graph it.
It'll be 1.05. He plug everything in. I got 1.05.
Alright, everybody agree on the 2 for the R?
Yeah.
Okay, I think I walked around and checked almost everybody's. 2 is fine. Okay. Alright, now, when we get into this tangent, we got a couple of things popping up. Alright, so I'm plugging in my Y and my X. And so I'm getting it down to this point where it's square root of 3. Okay, the first thing that you want to sort of be mindful of is that if it's something that you know off of your unit circle, you want to be using your brain and not your calculator. Okay? This one, remember we talked about this. We said this is not something that we know, all right? So we didn't have any choice but to use the calculator. This one I do know, okay? I know that where is tangent equal to square root of 3? Pi over 3. Okay, so I can do that one without using the calculator. And pi over 3 is a better answer than 1.25 because why? It's exact. This is a rounded answer. This is exact. It's better to be exact if you can. Okay, that's why we're not using the calculator there. All right, so that's the first thing you kind of got to be aware of is, you know, do I use the calculator or not? Is it something I know or is it something I need to calculate on the calculator? All right, now, the other thing that I want you to think about is, let's go back up here and let's plot this thing. All right, so if you don't know what square root of 3 is, you could come up with a decimal there for that. All right, so the point that we've got here, -1, -1.73. Okay, there's the rectangular point right about there. And then if I come down here and I plot my polar point that I just came up with, pi over 3 is like here. 2 out on that terminal side is going to place my point there. And the problem is now what?
It's the opposite.
It's not the same point. It's supposed to be the same point, right? We're supposed to be giving two coordinates that give exactly the same point. Okay, so what just happened? What did I do wrong?
You usually put an X in negative 2.
What do you think, Nathan? You figure out what I did wrong?
Your R is negative, so.
Your R is positive and negative with the square root. So both
Ah.
answers are positive and negative, and then you choose if it's negative.
Okay.
You gotta choose if you're doing,
You
and
can,
since it's not on, you gotta choose the one that's got it.
okay, you can do that. I think a little cleaner way to do it, did I look at the angle part of that? When I come up with an angle where tangent is equal to square root of 3, you guys automatically gave me quadrant 1 because that's sort of the easy quadrant to pull from, right? But we also know that it has a square root of 3 value in quadrant 3. Okay, so I think that the easiest thing for me to do is just make the adjustment there. I can make it on the negative, yes. All right, so what is the angle going to be? Not pi over 3, but what?
4 pi over
4
3.
pi over 3, yes. Okay. So what I have to do is I really need to graph these things just to check to make sure that what I'm saying is the answer is actually in the right format.
You could also do the negative 2 and pi over 3.
You could also do negative 2 and
Pi over 3.
pi over 3.
Because that'll give you your dotted line.
Yes, that'll work. Yes, you could also do that.
Be correct?
All right. Are you guys okay with that? Okay. All right. Okay, let's think about going the other way. All right, so that is, I give you rectangular, and you're giving me polar. So now let's think about if I give you polar, and say 6 pi over 6, and I want you to give me the rectangular. We're going to actually change the formulas. You could still use the same formulas, but I think it's a little easier if we switch it out. Okay. So, what they're doing formula-wise is this. Okay. Now, again, those formulas are not necessarily something that they've just sort of pulled out of the air. Point that we're talking about, right? Okay. Now, kind of think about overlaying that on a rectangular system and think about it being like a triangle. In order for me to get to that point, I would come over some x value, right? And I would go up some y value. And we already know that that's the r, the distance from the origin to the point. Now, if I were to ask you to come in here and find cosine of that angle, you would tell me what?
Adjacent over hypotenuse.
Square root of 3 over 2.
You would say x over r, right? And just kind of keeping it generic, x over r. Okay, now look at this formula, look at the x formula, and look at what I have on the board. Okay, how did they go from what I have on the board to that formula right there? They solve for x, and how do they solve for x? Multiply by r. Okay, so they took this equation right here, which we came up with just from using a triangle. okay, multiplied by r. And there's the formula that they're given. Okay, so again, and that's not necessarily something you have to know where it came from, but know that it's not any big deal. I mean, they're just saying, here's your right triangle, here's what you know about cosine, let's just rearrange the terms a little bit, and we've got a formula that'll work